Introducing basic differential equation. This video is focused on finding a general solution to a differential equation. So let's introduce our first differential equation. We have a dy dx. dy dx is you can call this a differential or derivative. dy dx means y prime. All right, so that y prime, you can say y prime is equals to x to the third minus 7x to the fourth plus 2. So we have a differential and an equation. So what is a general solution? General solution is I gave you what y prime equals to. I want you to find y for me. So this is a y prime from y prime to y. You can say we take the integral or we find the antiderivative. So we have y prime equals to x to the third minus 7x to the fourth plus 2. Finding y means we are trying to integrate both sides. So what is y equals to? Y is equals to integral x to the third minus 7x to the fourth plus 2 and then a dx. So what is that equal to? Y is equals to 1 over 4 x to the fourth, right? You take the derivative of that, you go back to x to the third, and then minus 7 over 5 x to the fifth, and then plus 2x, and then don't forget that this is an indefinite integral, so there is a plus constant c at the end, and then this is the final answer. So what is this answer called? This answer is called a general solution to the given differential equation. So general solution. Why do we call this a general solution? Because we have a constant c. So it can be any constant value, a 2, a 5, a -1, a negative pi. So since we don't know what c equals to at this point, we will just call this a general solution. So if you find out what c equals to, so let's say c equals to 5, you plug in 5, then we call that a particular solution, and we will do that in the next video because finding c requires an initial value. Okay, so let's do more example. The next one in green, we have a dy dx equals to 1 over x plus e to the x plus e to the 2x plus e to the negative ax minus e. All right, so let's find y. Let's find what y equals to. So we have a y prime equals to 1 over x plus e to the x plus e to the 2x plus e to the negative ax minus e. And then find y. So you can say we integrate both sides, or you can just go ahead and take the integral. So y is equals to integral 1 over x plus e to the x plus e to the 2x plus e to the negative ax, and then minus a constant e, and then a dx. So what is the integral of 1 over x? This is not a power rule. The integral of 1 over x is equals to ln. So y is equals to ln absolute value of x. The absolute value is required because ln negative is undefined. And then the integral of e to the x is still e to the x. And then the next one, the integral of e to the x is e to the 2x. What else is missing? Ask yourself. When you take the derivative of e to the 2x, you get e to the 2x times 2. You have to times 2 because by chain rule, you have to take the derivative of 2x, right? So there is a 2 if you do the derivative, but in the integrand, I don't have a 2, right? I only gave you a e to the x. So how do you get rid of the extra 2? The answer is you put a 1/2 in front. And then for the next one, you have e to the negative ax. So this we will have to put a negative 1a in front. So when you take the derivative of that, the negative a times negative 1 over a gives you back to a positive e to the negative ax. And then e is a constant, not an exponential function. So that integral of e is e times x. And then you also need to do what? You also need to do a plus c. So the plus c is just a constant. So since we don't know what c equals to at this moment, we will call this a general solution. So general solution. And then the next one is a cosine, right? The one in orange. And then we have a velocity, acceleration, and position function. So how about this? To save myself a little bit of space, I'm going to move this up, and then we do the orange problem. So let's go ahead and then write this down. We have a y prime equals to cosine of x minus sine of phi x and then plus sine of negative 4x. And then to find y, we integrate both sides, or you can just go ahead and do the integration. So we have cosine of x minus sine of 5x, and then plus sine of negative 4x, and then a dx. The integral of cosine is equals to, what is that equal to? Tell me. I heard sine of x, correct? So this is equals to sine of x, and then the minus is going to carry over. And then how about integral of sine? The integral of sine is equals to negative cosine. So let's use a parenthesis, negative cosine of 5x. How come I reserve some space? What is missing in there? When you take the derivative of cosine, you will get the negative sign, right? So the two negatives becomes a positive. And then how about the phi? By chain rule, that produces a phi, right? Because the derivative of 5x is equals to phi. So therefore, just like the previous problem, you have to put a 1/5 in front. And then the plus carry over, the integral of sine is equals to negative cosine. So we have negative cosine of minus 4x. And then this, I will need to put a negative 4 in there. So when I take the derivative of cosine of negative 4x, the negative 4 and the fractions got cancelled. And then don't forget that we have to add a c at the end. So this one is a general solution. So what I am thinking is when you enter this to your, when you do works online, you enter this, they might say this is incorrect. So this is one of the can be like one of the possible problem. We have to recall this. Sine is an odd function, right? So let's do this in red. So sine is an odd function. What does that mean? That means sine of negative 4x is equals to negative sine of 4x if they are not happy with having a negative inside the parenthesis. How about cosine? Cosine is even. So cosine is an even function. So if you have a cosine of negative 4x, cosine of negative 4x, what is that equal to? That is equals to cosine of 4x. So if you still see a mistake when on your when you do works online, maybe this is a problem. But to be honest, when I put this on a test, I accept cosine of negative 4x. Oh, don't forget that you have to clean up the plus and the minuses. All right, this problem is officially done, and then let's go ahead and do the last one. So the last one, do you see that I have a dv dt? So this is a v prime. I gave you v prime equals to negative 3t plus 10. I want you to find the position function, velocity function, and acceleration function. We talked about this in the past, but let's go ahead and review this first. So here is a quick review. So let's say we have f of x. So I gave you f of x, and then f of x represents the position of an object. Or you can let's don't use x. You can use f of t, because that makes more sense. F of t. So when t equals to a number, so let's say t equals to 5 seconds, you plug in 5 to the position function, you get a result. What is the result represents? The result represents the object where the object is at time equals to t. That is what a position represents, where the object is at time t. And then when you take the derivative of that, so this is the rate of change of position, we call this velocity. And then the rate of change of velocity, which is the double prime, we call this acceleration. That is how this works. So we have a v prime, right? So v is usually represent velocity. So we have a v prime equals to negative 3t plus 10. So this is the derivative of velocity. Then this is an acceleration function. The given is a acceleration function. And then how do you go from acceleration to velocity? So from velocity to acceleration, you take derivative. From acceleration back to a velocity, you will have to do what? You will have to do a integration, right, or antiderivative. So vt, that is equals to integral negative 3t plus 10 dt, and then vt, what is that equal to? That is negative 3 over 2, right, t squared, and then plus 10t, and then plus c. When you take the derivative of the velocity, you will be able to go to the acceleration, right? Bring the 2 down, and then the 10t becomes a 10. The c, we don't know what c equals to in this problem. And then let's just go ahead and find the position function. So to find the position function, you will have to take the integral one more time, right? So let's take the antiderivative one more time. So the position function, let's use position. Let me just use p. So that is the integral negative 3 over 2 t squared plus 10t, and then plus c, and then a dx. So we have that equals to, this is a third power, right? So you have a 1/3, then this becomes a 1/2. And then this is a square, 10 divided by 2 is 5, and then you have a c of x. So we are running out of letter, then let's just use d. So that represents position. Function. So if you want to just keep it simple, you can just ignore the c. So without the c, then this will be 1/2 t to the third plus 5t squared, and then plus c, if you ignore the c right here. All right. Okay, so that is the end of this video. If you like the way I teach math, give me a thumbs up, a subscribe, and I will meet you all in the next video. Signing out.